Hi guys, this is Mohammad P, a tutor on Chegg.com. Today we are talking about area of polar regions. So the only formula that you need in order to calculate the area of any polar curves is the formula that I'm writing here. That's A equal 1/2 integral from A to B r of theta squared d theta. R theta is basically the radius as a function of the angle theta. So let's look at one of the examples that I have here. So let's consider the function r theta equal cosine of 2 theta. In order to figure out how to find the area of it, first we need to visualize it and get the idea how the graph looks like. So let's graph this one. I'm gonna first graph r as a function of theta, like in an xy coordinate system or in a theta and r coordinate system. So this is cosine 2 theta. The amplitude is 1, so it goes to +1 and goes to -1. Also, I know the period is 2 pi over k, that the k is the coefficient of theta, so it's going to be 2 pi over 2, so it has a period of pi. So the graph of cosine function looks like this. So here is going to be one period, so it's pi. Because I need to go over 0 to 2 pi, I need to graph one more period here. So here is going to be 2 pi. So obviously here is pi over 2. Here is pi over 4. Here is 3 pi over 2. Here is, 3 pi over 4, yeah. And then pi, obviously here I have 3 pi over 2. And then here is 5 pi over 4. And obviously here is 7 pi over 4. Okay, so as you see, the graph goes pi over 4, pi over 4, pi over 4. So we have like sections of pi over 4. Now I'm gonna graph the polar version of this. So as you see, when the theta is 0, here is theta equals 0, I have the radius at 1. So at 0 degree, I start at 1. And as I go to pi over 4, the radius goes to 0. So I divide each quadrant by 2. Each portion is 45 degree or pi over 4, like this. Okay, now I start at 0 degree, and then the radius from 1 goes to 0. So I'm going to have something like this. Now I have from pi over 4 to pi over 2, the radius goes from 0 to -1. Since the radius is negative, instead of drawing like this, I'm going to flip it respect to the origin, so I'm going to graph something like this. Now I'm going to go from pi over 2 to 3 pi over 2. So here is pi over 2. Let me label this. This is pi over 4. Here is 0. Here is 3 pi over 4. Here is pi. 5 pi over 4. 3 pi over 2. And then 7 pi over 4. And then 2 pi. Okay. Now instead of going from -1 to 0, because it's negative, from pi over 2 to 3 pi over 4 is, instead of going like this, I have to go back this way. So this is my first direction here, and then I'm going, okay, so I have covered already from 0 degree to 3 pi over 4. Now from 3 pi over 4, the radius becomes positive from 0 to 1, so I'm gonna go like this. And then from 1 goes back to 0, so I'm going to have something like this. So I covered up to 5 pi over 4. If you notice, again, the radius becomes negative. So instead of drawing between 5 pi over 4 to 7 pi over 4 because the radius is negative, I need to flip it with respect to the origin, and I'm gonna graph it like this. So it goes to -1, which becomes 1, and then here. So I'm going like this. So I already covered up to 7 pi over 4. Now from 7 pi over 4 to 2 pi, it's again positive, so I'm going to stay here and then complete this. Okay. So this is the graph that you get for the cosine of 2 theta. Now we are going to find the area enclosed by these graphs. So as you see, we have 4 loops. Each loop's basically covers 1/4 of the plane. So it's really easy to find the area of one loop and then multiply it by 4 because it's totally symmetric and they all have the same area. So what I'm gonna do, I'm gonna find the area of this one. So we find the area for this, and then we multiply it by 4. If you notice, here is we can actually look at it as a negative pi over 4 to pi over 4. So a1, I'm going to call it a1, is 1/2 integral from negative pi over 4 to pi over 4 cosine 2 theta squared d theta. Okay. Now what we can do, we can actually write this as a double angle. So we have a1 equal 1/2 negative pi over 4 to pi over 4. This becomes 1 plus cosine of 4 theta divided by 2 d theta. That becomes 1/4 integral from negative pi over 4 to pi over 4. 1 plus cosine 4 theta d theta. Okay, so a1 is going to be 1/4 theta, and then the integral of cosine to 4 theta is going to be sine 4 theta divided by 4, and then we go from negative 4 pi over 4 to negative pi over 4 to pi over 4. Yeah. So if I substitute, I get 1/4. So pi over 4 minus pi over 4 becomes 2 pi over 4, which is pi over 2, and then the sine of pi minus sine of negative pi, that's going to be 0, so we consider this 0. So a1 is going to be pi over 8, so a total is going to be 4 a1, which is going to be 4 times pi over 8, which is pi over 2. So the whole graph encloses pi over 2 of area. Okay, so that's basically it. You can do like more problems on your own and practice this. They all have the same concept. I really recommend that you graph it first and then visualize it and then use the formula to get the area. I hope that you all enjoyed, and I wish you the best. Have a wonderful day. Goodbye.